with us, we have today we have multiple panelists, multiple profs, advisors, as well as other students with us that will give us presentations about their experience in the physics program. And yeah, hopefully, if you have any questions, feel free to ask them at any time. And again, if you are not in physics, if you're not in the right room, make sure to go on the Teams chat, select the right program, right room, so that you get the best experience for your program. So we'll get started in just a minute. Just give me a second. I'm just making sure everything is clear. All right. So perfect. All right. So we'll get started. Before we start, I want to introduce who's going to present. I believe it's Richard here who will present. Okay, would you? Yes. Hi. Sorry about the background noise. Would you like me to present the PowerPoint? I have the PowerPoint. So would you like me to screen share it or?
Yeah, you can screen share it. And then changing the slides, I'll just say change slide or something.
Yep. I'll use my eyes and hopefully I can and my ears and hopefully I can guess when there is a slide change. All right.
Awesome. Thank you, David.
So keep in mind there's about 63 people on, which means we only have a fraction of the number of our incoming students on the chat. So
yeah,
we could delay if
we could definitely wait 5 minutes more before we get started. So yeah, I guess we'll get
that. Yeah, that's a good point.
Yeah,
we may not have all received the update.
So in the meantime, what I will be doing is I will be sharing with you advisors and profs a Google document where you will be able to see questions more filtered questions. Our moderators in this chat are just taking questions from the chat and they'll be transposing them into this Google Doc so that you can just read from those questions instead of the chat. So.
And the link to the Google Doc?
I'm sharing that to you right now, actually. I'll be sending those in private to all of our advisors. Give me a second. Participants, Richard up.
So I can't get my chat operating. It says chat in channel meetings is only available to team members. I thought I would be a team member. So I can't see the chat. So if you send it to the chat, it might be hard for me to get.
I'm sending it to you in private, actually. So that probably gave you a notification. Hopefully that worked for you. Figure these out.
Yeah.
You got this? Perfect. Would you like me to send this to the other advisors, or do you have a better way to send this to the other advisors then? I can send those to the other advisors. It's just if you have a better way, maybe.
Well, maybe do it a couple of ways. Maybe by email, and maybe just the way that you did it now.
Yeah, I'll continue doing it.
That either, by the way, for some reason.
Yeah. Sadly, I don't think there's going to be a fix for that. I believe it's a little issue. I'm sorry. This is kind of
changing permissions to see if that will somehow get you in, but I'm not totally sure.
If you send me the link to Stefan Ejuk, then I will email it to the other people.
Okay.
I have all their email addresses.
Perfect. Thank you. I'm doing that right now, actually. This Google Doc will be. Oops, I believe I sent the wrong link, actually.
It's biology that you sent.
Yeah. I'll be sending the right one in just a minute. Sorry about that, everyone. Yeah, I'm resending a new one. This one should be the right one.
Okay, so advisors, who needs it? I've got Brian, Michael.
So Brian, Michael, Richard, and
Bayun.
Bayun. I believe. Is Brenda Lee here?
Brenda's here.
Yeah, anyone else?
Mike Fick.
Okay.
What I can also do is try and make like all of the advisors and profs an attendee, which might allow you access to that just for future.
Yes, that would probably work as well.
I'm here too, Stefan, Monica.
Whoops. Okay.
Sorry, a bit
No
too late.
problem.
Okay, great. I clicked on the link you sent and it works.
Perfect. All right, so our moderators, we have multiple moderators in this chat right now who will be filtering through the chat. They can see the chat and they'll be just pasting questions into here so that you only have to look through those questions.
I still don't see the chat.
Yeah. Vivian, what's your...
I am trying here. Let me go all the way.
Brian, I just sent you an email. It has a link in it, and that link takes you to the Google Doc where the questions will be.
Thank you.
Sorry about all the... It's a very last minute change. We're having some issues with WebEx.
Yeah. To say the least.
Yeah, it is definitely... Yeah. All right. So thank you everyone who's showing up still. Thank you everyone who's here. Thank you for your patience. Again, I'll introduce myself again for those who are new. My name is David Rene. I'm in third year mathematical physics student, and I'm joined with Vivian here.
Hi, I'm Vivian. I'm going into my 4A of biomedical sciences, but this is the physics room, not the biomed room, and I am a logistics coordinator.
Yeah, and I'm a leader coordinator. Thank you again for your patience. We'll get started in a couple minutes from now. We're working on getting everything figured out properly so that we can have a clean and fun event for everyone. If you have any questions, feel free to ask in the chat. We have moderators, hopefully they're working right now, and copy pasting those questions in the chat.
I haven't gotten your email yet, Stefan, so I'll just have to wing it here.
So I believe we should be able to get started by 11:25. Hopefully it's a good time.
So David, will we then be able to go a little bit over the 12 o'clock?
I believe so, yes.
Yeah. So we'll just sort of proceed as normal.
Yeah.
Right? Is that the idea? And
That is absolutely.
just get pushed back a bit. Okay.
Yep. Yep. I'm just looking through the chat right now. So everything's fine. Perfect. All right.
Yeah, so notice I don't have the ability to share this presentation, so it will be up to you to do that.
All right, perfect. Well, I'll start getting it prepared then. Do you have a version of yourself so you can see the speaker notes?
Yeah, I'm fine with that. Don't worry about the speaker notes.
Okay, great, perfect. All right, so I'll start sharing right now so that people can see. People can have a little something to look at. All right, can everybody see my screen correctly?
Yes.
Yep.
Perfect. All right. So great, perfect. So yes, again, thank you everyone for showing up. Thank you for your patience. We'll get started in just a minute from now, making sure everyone has access to all the resources. And yeah, If you have any questions, you can already start sending them in the chat. We'll be keeping track of every single question we see, and we'll get them answered in the Q&A part of this session. So yeah.
David, just so you know, we can see your screen. Perfect. So I think we can start the presentation if everyone is ready now.
Yep, I'm ready. David, you're on mute.
Thank you. Yeah, so we'll get started. Thank you everyone who's here. I'll introduce myself one very last time for those who just joined. So thank you everyone. Thank you for your patience. We're having some issues again. So we last minute changed to Microsoft Teams. So thank you for showing up. So I'll introduce myself. My name is David. I'm a leader coordinator this year for science orientation. I'm also a third year mathematical physics student, and I'm here with Vivian.
Hi, I'm Vivian. I'm going into my 4A of biomedical sciences, even though this is the physics room, and I am your logistics coord. And without further ado, let's start this presentation.
Yeah, let's start with this presentation. So we'll give the speaking rights to Richard here.
Thank you, David. So hello and welcome, everyone. So to the Successful Scientist Orientation Session in Physics and Astronomy. So my name is Richard Epp. I'm one of your advisors, your academic advisors. So the first thing I want to say is, you know, you've chosen to be in the discipline of science, and this is a fantastic choice. So over the past few centuries, science has emerged as perhaps one of the most powerful disciplines in making the world a better place. And it's also one of the most interesting, exploring all aspects of our deeply mysterious universe. And physics and astronomy looks at some of those mysteries at the most fundamental level, everything from subatomic particles up to the entire cosmos. So it's a fantastic choice. And the main message of this presentation is that there's a lot of people here at the university who want to help you succeed. David, can you flip that slide, please? Awesome. And I also wanted to welcome you to the university, university life, University of Waterloo in particular. So you're entering the hallowed halls of learning, you know, traditionally reserved for the best and the brightest minds, and that's what you are. You're the future of our society. And I just want to remind you that university is not about, you know, filling your head with knowledge. You know, we have the internet for that. It's really about transforming the foundations of how you think. okay, to creatively solve problems. It's a huge intellectual and personal transformation. And it's up to you, to make it one of the best experiences of your life. But it's going to require you to be working harder and smarter than ever before. I also wanted to welcome you in particular to our department, the Department of Physics and Astronomy here at Waterloo. So it's one of the largest, most comprehensive physics undergraduate programs in Canada, with a world-famous co-op program. It's a rich and powerful learning environment, but remember, you only get out of it what you put into it. And it's also one of the largest, in association with Perimeter Institute for Theoretical Physics and the Institute for Quantum Computing and the Quantum Nano Center and the department itself. It's a real research powerhouse. So it makes it one of the largest physics graduate program in Canada. For example, on the left there, you might recognize Donna Strickland, Nobel laureate in our department. On the right, you might recognize the first direct image of a black hole. Avery Broderick in our department was a key member to help us reach this colossal human achievement, and many, many more examples. So Waterloo is a fantastic place to study and do research in physics. It's a really great choice. And we're going to hear a few words from our department chair, Professor Brian McNamara. So he does research in astrophysics, in particular supermassive black holes and galaxy and cluster growth rates. That's his day job. How awesome is that? Okay, and he's also our fearless leader, working tirelessly to constantly improve the learning and the research environments here in the department for you. So over to you, Brian. So Brian, you were on mute there, Brian.
Okay, so sorry about that. Thanks, Richard, for that kind introduction. I just want to welcome all of you to the department. There are about a quarter of our incoming class have joined us today. It's been a very strange year, as you can imagine. And in fact, a pretty heady several years with the Nobel Prize win and then big announcements that we've had that Richard mentioned about the first image of a supermassive black hole, something that was led by Avery Broderick, who was one of our faculty. And there is so much more exciting science going on in the department. To just amplify a couple of things that Richard said, being a physicist is a very exciting choice. This will be likely the hardest 4 or 5 years you have spent, and for many you will ever spend. It's an extraordinarily difficult subject to master, and in fact, I would argue that no one ever really masters it. And to amplify again what Richard said, you'll get out of this what you put into it. It's extraordinarily difficult. It takes hundreds to thousands of hours of very hard study to understand the depth and the beauty of what you'll be learning. And when you emerge from this, you will have very powerful tools to change the world and make it better. And the nice thing about a physics degree is you can go anywhere with it. If you want to become a physicist, a research physicist, astrophysicist, biophysicist, you can do that. If you want to become an engineer eventually, you can do that. If you want to go into business, law, almost any discipline, a physics background is key. It teaches you to think, to break very complex problems down into models, simple models that then can be used to understand how a much more complex object works. And that is a valuable tool that few in the world share. And so I'm really excited that you chose to come to Waterloo. One of the other aspects of being in university is not just taking your classes, and I assure you your classes will be very difficult. They'll be stimulating. We have some of the best professors, the best teachers in science, in physics, and so I'm sure that you will enjoy most, if not all of your classes. They will be very difficult, but also avail yourself to other events going on at the university. I realize that this is going to be very hard given our current COVID situation, but we will get through it. It's tough to start your first year online, but it's going to be a learning experience for all of us. We're pulling out all stops. All the faculty are pulling out the stops to become available to you virtually, so that you can proceed through the program essentially unimpaired by this unfortunate circumstance. The other thing I want you to do is really consider joining PLA, the Physics Learning Accelerator. That's there to help you understand some of the basic concepts. For some of you, it'll be a refresher. For others, you may be learning a few new things about vectors and force diagrams and so on, rotational motion. This is an optional, but I think very important part of getting you going and leading you toward a successful future here in the department. And also, be aware that there are a lot of seminars. And so as you're thinking about what you want to do in the future, keep your options open. There are many opportunities. We're an entrepreneurial university. So those of you who want to start businesses, look at Velocity Science. I think it's been renamed and I've forgotten the name of it right now. But there are, opportunities in that direction. But also, there will be myriad seminars and so on that you'll be welcome to join, both in the department, at the university as a whole, at Perimeter Institute, and so on. So please avail yourself to all that's happening here. If you have a problem or any questions, you know where to find me. You can find my my email address on the web page, and I'll respond to you as fast as I can. And I just want to just let you know that it's been one of the pleasures of my life to have the opportunity to chair this department. I enjoy it very much. I have marvelous colleagues. We have wonderful students, and I just want to welcome you to our community. And with that, I'll turn it back over to Richard. Thank you very much.
Thank you, Brian. So another important person in your lives will be our Associate Chair, Professor Michael Ballo. So he is also in astrophysics, working on galaxy growth rates, large-scale structure, and so on. Fascinating research that he's working on. But he's also in charge of undergraduate affairs. So Brian and Michael work closely together to try to make the University of Waterloo, the physics department here, the best place to study physics. And he will be, I think Brian as well, will be available at the end of the session if you have questions. David, can we switch the slide? Awesome. Okay, so also really important in your life here at the university are your academic advisors. So first off, what are academic advisors good for? Well, academic support. Okay, so there will be all kinds of situations under which you might need some advice on course selection. Maybe you want to take a minor, maybe you want to, change your stream of physics and so on. Maybe you have some troubles in the course. Anyways, we can help with course selection and selecting your electives and so on. We can help make sure that you're meeting your academic requirements. And we can consider plan modifications if you want to switch from one physics program to another or add a minor. Or if you're in co-op, we can talk about sequence changes, changing your work-study sequence. If you're thinking about an international exchange, we can help plan courses around that. If you're having some troubles with your grades, we can certainly talk about that and talk about strategies to achieving academic success and a whole bunch of other things. Okay, so, and if we can't help you directly, we can make referrals to a huge array of University of Waterloo services and resources. Remember, this is a large university. There's like over 30,000 students. The university has powerful services and resources available for you: counseling services, health services, financial services, services if you're an international student, on and on. So we're aware of those services, and we can tell you how they can help you. So just generally, if you have any kind of a question and you don't know where to go, just talk to your advisor. Just email them or meet them on Teams, and we can either answer your questions directly or we can refer you to the right place where you can get answers. The main message here is there's a lot of people here that care about you and they want to help you succeed. You just got to ask, and help is on the way. Okay, so who are your academic advisors? So there's two general purpose advisors. That's myself and Professor Stefan Ejek. So we do a lot of work in the background, but you also can occasionally interact with us directly. We're always happy to help, and directly to the right person if need be. Okay, but then you are in a particular stream of physics. Program-specific advisors would be, if you're in honors physics, you would be contacting Professor Bae-Yun Ha. If you're in physics and astronomy, you'd be contacting Professor Mike Fick. If you're in math phys, you'd be contacting me. And if you're in life phys, you'll be contacting Brenda Lee. And if you're in M&S, the M&S students are housed under chemistry. They're in the chemistry room right now. And we also have Chinbin Liu, who is the China 2+2 advisor. So these are all of our advisors. The first four are the ones that you would mainly be interested in, unless you're in M&S and you contact Rick Marta. So I just want to put a plug in on September 14th. We're going to be having an advisor panel discussion, Q&A session that provides a little bit more time for you to ask questions. So we're going to be introducing ourselves and our program, the benefits of our program, and so on, and then opening it up to all of your questions. So that's going to be happening on September 14th. And so just pay attention. We'll be just sending out some information about that. Okay, and these advisors, Bae-Yun and Mike Fick and myself and Brenda Lee, as well as Stefan Ejek, will be here at the end of the discussion if you have some questions for our 5-minute or 10-minute question and answer period. Okay, and one important thing to mention here is if you have any kind of general questions, your first point of contact is the physics undergraduate office. So right now we have Monica Kitor there. And so if you have any kind of general questions, what courses are being offered this term, who's instructing those courses, look, I'm having trouble enrolling in these courses, can you help me? I need a course override, how do I do that? There's important dates that you need to be aware of, the withdrawal date from courses if you're not doing well in a course, various administrative procedures, and the undergraduate office also is keenly aware of all of the university resources, the Student Success Office, counseling services, financial services, and so on. So if it's a general question, your first point of contact is the physics undergraduate office, and the contact information is on the physics webpage. If you have a program-specific question, then contact your academic advisor directly, either through email or also for some of the advisors, they're available on MS Teams. When you're doing any communications at the university, all of your university communications should use your @uwaterloo.ca email. If you use, for instance, Gmail or something, chances are it's going to go to a spam folder. So make sure from now on, with all communications with your advisor and everyone else, you use your uwaterloo.ca email address. Much appreciated. Okay, and so the way the structure works is we've got sort of science, the Faculty of Science at the top, and then there are 4 departments, physics and astronomy, chemistry, biology, and earth sciences. So you have program-specific advisors at the level of your department, physics and astronomy, but you also have more general purpose advisors at the level of the science undergraduate office. So they can help you with all kinds of general questions, concerns, changes to your program, things that are not course-specific or program specific. They're also a great resource and really willing and able and available to help. Okay, so what should I know about first year? Brian and I have said a few words to sort of, a bit of an inspiration for joining physics. It's a fantastic program, but it's also important to know that you're really going to have to work hard. Okay, so I want to just sort of outline roughly kind of the difference. You're transitioning from high school into university. And so I'll talk a little bit about high school, some high schools, and what's different in that transition from high schools to university. So in some high schools, you really didn't have to prepare for class. You just show up and you listen. In university, it's different. Okay, so before you view an online lecture, you should prepare yourself. You should do some reading in advance in the textbook. You should have done some problem solving and so on. You should be prepared for the lecture so that when you watch the lecture, you'll get more out of the lecture. Okay, so prepare for your lectures. In some high schools, teachers, taught basically everything that you needed to know was taught in the class. In university, it's very different. University courses are a lot faster paced. There's a lot more material to cover. And so instructors really only have time to focus on the main concepts, the main principles. And then the rest is up to you to fill in all the details. And oftentimes that's filled in by reading, that's filled in by group discussions, all kinds of activities in the class that will help fill in the rest of those details. In some high schools, sometimes homework was assigned, sometimes not, maybe not a lot. In university, it's very different. Okay, so you need to do regular studying outside of class. So most of your time in a course is spent outside of class, regularly studying and reviewing, working on assignments, working in peer groups and so on and so forth. Just to sort of generally summarize, in high school, think about, 80% of the learning happened in class and, 20% happened independently outside. In university, it flips around. This is super important for you to recognize right away. The sooner you sort of change your way of thinking about learning, the more successful you're going to be. And another couple of differences here to point out. So in some high schools, you had a limited independent work, thinking for yourself. In university courses, again, it's very different. Many physics courses, they really stress the idea, just think for yourself. Just think like a physicist, just figure it out. So you figure that out, by reading, by talking to your peers, group discussions, all that kind of stuff. In some high schools, what does it mean to have mastered the material? What it means in some physics courses in high school is that you are taught to solve specific kinds of problems. And when you come to a test or an exam, it's those same problems that appear, and then you can just solve them, right? At the university level, again, it's very different. Mastery of the course means that you've learned the basic principles well enough that you're able to apply them to solve new problems that you've never seen before. Okay, so it's very different. The mastery level is different. In high school, effort certainly counts. In university, it's really hard to see your effort, right? And so the only thing that counts in university is results. Okay, so some will take an enormous amount of effort to achieve certain results, some will take less effort, but really it's only the results that count. In some high schools, maybe others were around to help remind you of your responsibilities, help you with decisions. You had teachers, you had guidance counselors, and so on. And at university, again, it's a little different. It's hard for us to see exactly, where your mental health is at, where you're struggling in courses with concepts and so on. You have to learn to ask for help. We're all here to help you succeed. There's a huge resources available to help you succeed, but you have to ask, learn to ask. Okay, and then help is on its way. Just think about in high school you were sort of like an amateur student, and in university you're a professional student. This is your job now. High school is a little bit more of a teaching environment. University is a little bit of a more of a learning environment, where there's a lot of learning that happens on your own and with your peers. Okay, so just a word about university life. I just want to emphasize here, work matters. Okay, so you've entered the discipline of science, in particular the discipline of physics. It's a discipline. Okay, I said that word 3 times. Okay, it requires an average of 8 to 10 hours per week per course. You're taking 5 courses probably. That's like 40 to 50 hours per week is spent on your university. This is a full-time job. Okay, and the stuff happens fast. There's a lot of material to cover. There's a lot of sort of deadlines and so on. Time management is a super important skill. So within the first week, I would hope that you guys are able to come up with a study schedule. I'm going to spend certain times of the day here and there working on this course and that course. Your whole schedule is full, 40 hours a week, 50 hours a week. Make a study schedule and stick to it. Find a place to study where you're not doing anything else. This is your study spot. And the Student Success Office can help you with time management skills and other study skills. Also, the focus here is on learning. It's really important to get a textbook for your course and to learn by reading. Okay? As you get to more and more advanced courses, you learn more and more by reading. You know, you're going to be in many courses, you'll be in peer groups. Learn to work in peers, learn to share your ideas, learn to talk. Also, you know, unfortunately, the lectures will be remote, but, you know, the instructors have put a lot of effort into them. You know, prepare for the lectures and learn to learn from these remote lectures. And really make sure that you connect with your instructors. If you have questions, if you have problems, your instructors are super happy to help. The teaching assistants, the TAs are super happy to help. You know, your peers are happy to help. Really stay in contact. Talk to people. Don't be isolated. Okay? Don't keep yourself isolated. Really stay motivated. That's one of the hard things. And love physics. You know, focus on learning, not grades. If you learn the material well, the grades will follow. And it just goes without saying, don't cheat. You don't want to mar your academic integrity. Okay, so work matters, but so does play. So build in personal time, social time. It's really important. Get enough sleep, eat wisely, exercise, build a community network, talk to people, talk to your peers, you know, through Phys 121 group sessions. Talk to your upper year students through various clubs and so on. Monitor your mental health. If you have any trouble, let us know. We're here to help. Okay, so who can you ask for help? Well, as I mentioned, so through courses, your instructors and the teaching assistants are super happy to help. So just contact us. There will be office hours or Q&A sessions. Go to those sessions, speak up, ask your questions. We want to help you. Make sure that you pay attention to the Learn website for each of your courses with important course information updates. Just look at those daily. You know, again, talk to your peers, upper year students. There will be online drop-in tutoring sessions. In some courses, there will also be specific help sessions. So Physics 121, for Physics 121, as Brian mentioned, there's the Physics Learning Accelerator, which I'll say a few words about in a second. And then outside of courses, you know, talk to your advisor, you know, contact the Student Success Office, counseling services, etc. The main thing is there's tons of services and resources available to help you. We want to help you succeed, but you need to learn to ask for help when you need it. Okay, don't wait, just ask. Okay, so the last thing here is the course-specific help for Physics 121. So Steve Pfister, you see on the right there, he's behind this program called the Physics Learning Accelerator. It's a fantastic program. Everyone comes from different high schools, different background levels of preparation and so on. These are enhanced tutorials to help you move from a high school sort of mode of thinking to a university level mode of thinking for learning and problem solving strategies. So this is very important. So next week, all students are required to take the online physics prep test if you're in Physics 121. That's September 8th to 10th. We'll give details starting on September 8th. Those details will be available, you know, where to log in and so on and so forth. You need to take this physics prep test. So it just gives us a sense of, and yourself, a sense of where you're at in terms of physics and math preparation. And then students who don't do well in the prep test will notify you, and you'll be strongly encouraged to attend these PLA sessions. They're a great resource. And in fact, all students will have access to these asynchronous support materials. So it's a great resource to take advantage of. The schedule will be is to be determined. We'll announce that on September 8th with your Physics 121 Learn material available on Learn. And that's it from me. So thank you very much. Welcome again to our department. We wish you all academic success for this term and for the rest of your terms here. And so now I'll turn it over back to David to start the student panel.
All right, perfect. Thank you very much, Richard. Very insightful, very great. A lot of resources there. They're really important. Thank you very much. So we'll move on towards a student panel right now. So we'll have a few students who are currently upper years and physics degree or physics related degrees, and they'll be answering your questions. So the advisors as well as the professors will be answering your questions right after this. So without further ado, I'll present our panelists. So we have Amin with us, Jocelyn, and Lily with us. So if they could possibly turn their camera on and their microphone on as we speak right now. Okay, let's see. I see Lilia. Ooh, do we have Amin? Just give us a second, get things prepared. We have Lilia with us now. Trying to see Amin and Jocelyn. Yeah. All right. Amin, can you say a word if you are currently unmuted?
Hello, everyone.
Your mic is very, very quiet.
How's this now?
This is still very quiet.
All right, we'll just keep it up until it starts working.
We really can't hear you, Amin, actually. So if you could maybe find a solution for that. For now, Lilia, can you mic check?
Yeah, I can give a little introduction while we
Yeah,
wait.
go ahead.
Hi, my name is Lily Surbaru. My pronouns are she, her. I'm currently in my 2A term of honors physics with co-op, minoring in astrophysics. And I just thought I'd share one thing I wish I knew going into my first year, and that would be better time management. With many different due dates for like labs and quizzes and projects, it's really easy to forget some of these due dates until maybe like the night before something's due. So I would suggest keeping a physical or a virtual planner to keep track of your due dates and even to keep track of like allotted study time. Like when should I be studying for this course? How many hours a week? Type of thing. That way it'll help you stay organized and not miss any important deadlines.
Great, perfect. Thank you. Can I have Jocelyn now?
Hi.
Oh, perfect. That's great. Your microphone is good.
Awesome. I'm Jocelyn. I'm going into my fourth year, the 4A term of mathematical physics at Waterloo. I usually use she, her. And just something interesting, I'm also in co-op. So for everybody in co-op, there's lots of cool opportunities coming up. One interesting co-op term I had was where I worked in a laser lab in Poland for 8 months.
Great, perfect. Thank you, Jocelyn. Now, Amin, maybe?
Hello, everyone.
Yeah,
I hope you can hear me now. Hi, my name's Amin. My pronouns are he, him. I'm going into my second year of honors physics. And the thing that I wish I had known was the importance of working in a group while studying, because it really helps cement the material into your mind if you're working with and collaborating with other people while studying. So definitely keep that in mind.
Perfect. So now we'll move towards, so a Q&A. So right now, if you have any questions for our panelists, so either Amin, Jocelyn, or Lily, you can go ahead, ask them any questions you feel are important. And you can also ask questions to our advisors and profs at the same time. We're keeping track of every single question, but if you have any questions that are directly related to Amin, Jocelyn, or Lily, please let us know. We'll just give them a couple minutes. So, just give it a second. Well, I have a question for you guys. Anyone can answer. It's a free, open question to any of you. How did you find the difference in difficulty from first year to upper years? Anyone would like to answer?
Well, I'm only heading into my second year, but I did manage to take a couple of second year courses over the summer, the spring term. So the main difference to me, I was taking a math course. The main difference that I found was like there was a lot more like self-study, and like you were often like before lectures you were expected to know all the concepts before coming to the lectures. So like definitely there was a lot of self-study involved in that aspect. So that was one of the main big differences that I noticed from first and second year courses. Yeah.
Yeah, I can expand on this a little bit. So I'm going into my 4th year, so I've done 2nd and 3rd year courses. It kind of depends on the course in a lot of cases. So some of the 1st year courses are going to be, making sure everyone's caught up, and because people came from different high schools. So then once you're going into like 2nd and 3rd year, what everyone's already learned. So you can so there can be a jump, especially in like, say, the 2A or 2B terms, where now we know everyone's on the same page. So then you can start to get into information assuming everyone knows the same thing. It will, again, kind of depend, because a lot of times difficulty tends to depend on what specific aspect of the course you enjoy or are good at. But there can be that jump of at least everybody's kind of on the same page for how much material they know going into kind of the upper year courses.
Perfect. I see there's a question in chat for both Jocelyn and Lily. So it says, what were all of your co-op positions? Were they all related to your discipline?
Well, just for me at least, I'm only going into my 2A term, so I currently haven't had my first co-op term. That will be in the winter term, so my 2B. So I will pass this question to Jocelyn.
Yeah. So some of the co-ops I've done, a lot of mine have been quite related to to my degree. And it's been nice because I've actually gotten a chance to try out some different things. So my very first co-op was actually doing being an analyst for the government, which I thought was interesting because I was wondering whether that was something I'd want to try. It's really easy to, with a physics degree, go into being an analyst for different types of things like finance or government, just any sort of data, because you are building the skills you need in order to do that. So I had a chance to, for 4 months, just try out being an analyst. And that was neat because I got to get an idea of whether that was something I would enjoy. I've also had a chance to do some more like physics-specific research, like I worked in a laser lab in Poland, and I also worked at the National Research Council doing more computational chemistry type kind of theoretical physics stuff there. So there's some really interesting different things you can do, and it will really depend on what you end up doing, and also specifically what your interest is within your specific discipline.
Great, perfect. Just another question I'll follow to you guys directly. There's a question that says, is it fine for students to have a part-time job during university or no? Anyone here would like to answer? I can answer this question if none of you have had part-time jobs during uni. All right, so I'll turn on my camera, sorry. All right, so I'll answer this question. I believe it's fine to have a part-time job during university. The key element is to make sure that you know how to balance your part-time job as well as your studies. It's really important to know how many hours you can personally take on yourself. This is a very personal question. Personally, I know I need a lot of time on my studies because I need to study and I need to do questions. So I never do more than 8 hours a week. So I do a part-time job, but I only have 8 hours. I hope that answers your question. Obviously, some different jobs may require more outside of work time, and so it's really personal. So hopefully that answers your question. All right. We have a question here. Sorry, I'm trying to filter out through the questions. A question for Jocelyn. You mentioned your co-op position in Poland was 8 months. Did that count as 2 co-op terms?
Yes, it did. So the way that it normally works for co-op in most of the physics programs is that you do your first year, your first full 8 months of school. Then your first summer is off. So in my case, I ended up getting a summer research position. I know a lot of other people, like I think Amin, you took courses. And some people might go traveling. So that first summer you can kind of do whatever you are wanting to do. Then after that, in co-op, you would then, in your 2A term, so the first fall term of second year, be looking for co-op jobs for the winter. Then you come back to school actually in the summer, and then you go on to an 8-month co-op term. So that's 2 co-op terms in a row. So you can either do one job for 8 months, which is what I did, or other people will do one job for the first 4 months and another job for the second 4 months. That way we then end up going back to school for a second summer, and then back on co-op in the fall, school in the winter. Co-op, our last co-op, which is the one that I just did, is in the summer, and then our final year is a full 8 months of school again. You should be able to find that if you look under the co-op schedule, because different programs will have different co-op schedules, but for most of the physics, that's kind of the schedule you'll be using.
Great, perfect, thank you. I see another question here. For the first co-op, how important is having previous job experience? So I believe Jocelyn here is the only one other than me who's taken co-op before. So I believe I'll try to answer this question to my best ability so that it's not only Jocelyn talking. So how important it is having previous job experience? It really depends on the jobs, but most of the time it really is not that important. Most previous job experience are sometimes unrelated. For example, I've worked in a Tim Hortons before. It's a great working experience, but it's not really relevant to my co-op jobs. So how important it is, I'd say it's good to have it. It's good to have previous work experience because it shows that you can work in a team or in a very professional environment. But if you don't have work experience, there are definitely other ways to make yourself shine, I'd say. So it's important to have previous job experiences, but if you don't, that's still fine. You can be someone that's really good if you have volunteered before or if you've been in clubs before. So people are looking for very different experiences when they're hiring people. So it counts, but there are always other opportunities for you to shine. So that's my answer. I don't know if Jocelyn wanted to add something on this.
No, that's a good answer. Definitely, it can be tricky going into the first co-op term, just getting used to what it's like to apply for jobs, because that can be a new thing. One nice thing is one thing that honestly might be even more helpful is if you've had the experience of applying for jobs before, because that can be hard, is learning how to do that. But the great thing is there's a lot of resources to help you learn how to apply for jobs in that first term. So that's the big thing, is learning how to apply and having different experiences that you've had, but what experiences you have had really can be a variety.
All right, great, perfect. I see a question for Amin here. So how soon should we start looking at applying for a minor? And if we have an elective second term and we select the required course, do we automatically commence our minor?
In most cases, the department does like you to announce a minor. You can start looking for minors like as soon as you start university, essentially. Basically, start looking at things that really interest you and you really want to kind of continue on. And then the proper method of applying for a minor would be going to your undergraduate advisor and letting them know that, hey, I'm planning on pursuing this minor, and then they'll kind of do a course modification, and an advisor can correct me on this, where they'll add the minor onto your plan as well. And then from that point, basically all you have to do is satisfy the requirements, and you'll have your minor. Yeah.
And I just want to add on to that, in a remote sense, if you go onto the University of Waterloo's website and look for something called a plan modification form, just since we can't physically, not all of us can go in to go see an academic advisor, I believe there's a PDF online that you can fill out and email to the science undergrad office.
Yeah, great, perfect. We'll take just a couple more questions. After that, we'll move towards more advisor and prof questions. So one question I'll answer myself. How does this co-op system work? Do students have to find a place to do co-op, or are students assigned to one? So the co-op system, how it works, it's a competitive system. So you'll be the term before your first co-op term, you'll be given access to this website called Waterloo Works. And this website really is just a listing of all the jobs that are available. And it will be your job during that term to apply to all the listings that you find interesting, and then you go through the hiring process for those jobs. And so this repeats every co-op term. So every term before your co-op, you'll be given access to this website for listings, and then you'll have to apply through these. Don't worry, it's still a bit of time from now. You'll get to learn more about this website. So don't stress about this. All right. Yes. So another question for Jocelyn. What are the differences between Hunter physics and mathematical physics? Go ahead, let us know.
Yeah. So the big difference between honors physics and mathematical physics is going to be the math courses. So I'm in mathematical physics. So for us, we take our courses through our math courses through the math faculty. So specifically, the first year is going to be quite similar between honors physics and mathematical physics, except instead of doing calculus for sciences and linear algebra for sciences, you'll be doing linear algebra for mathematics and calculus for mathematics if you're in mathematical physics. After first year, it starts to diverge a little bit in that mathematical physics no longer is required to take labs and instead does more of a math-heavy course load. So we split up some of our math courses, like several of our calculuses, some upper level calculus courses called like partial differential equations and different differential equations courses. We have specific courses for those. Versus in physics, in honors physics, you're going to be heavier on learning labs and taking, say, some more condensed math courses that are all put together into a kind of mathematical physics course. So it really starts to kind of diverge after about first year, where you're starting to get more math heavy versus doing lab heavy for the two programs.
Right, great. One last question for Jocelyn, and then we'll move towards questions for panelists and profs. So what sort of opportunities do undergrads have for research? Do you have to be in the co-op stream to participate? Question mark.
Yeah, so definitely there are opportunities for research for undergrads. So co-op is one of the opportunities. So there are, on our co-op website, Waterloo Works, which is one of the places where you'll be able to apply for jobs, there are different research positions that will get posted. For example, the research I did in Poland, some of the professors from like the Institute for Quantum Computing will post research positions on there. There is also opportunities if you're not in co-op. If you are interested, you can look into a program called EDGE, EDGE. That's a program for non-co-op students to basically help with professional development and looking for different work opportunities in the summer terms, which you have off in non-co-op programs. And yes, there are opportunities for research. Like I have other friends I have a friend who volunteered with a professor in first year, or who have been able to discuss with professors and then research with them during their co-op terms. So yes, there's definitely opportunities for research. It's great to be able to look into some of the research your profs do as well, because they do really, really cool research.
All right, great, thank you. We'll move on towards some questions for our panelists. If you want me to distribute the questions, I can for our advisors. So thank you to all our students. Sorry, thank you for Lilia, Amin, and Jocelyn for participating, answering questions. If you have any more questions for them, you can always email us, and I'll make sure to transfer your question to them. So now we'll get some answers from our professors and advisors for some of these questions. So we'll try answering as much as we can, but there are a lot of questions to answer. So we'll get started from the top. So first question we have is, how will online exam proctoring work? I don't know if any of our advisors would like to answer this.
I guess I could address that.
Yep.
As the associate chair. So I think one of the challenges you're going to find is that there's going to be a fair bit of diversity in the way courses and evaluations are being delivered across campus. There isn't a set of rules that is being applied, not a set of specific rules being applied to all classes. I think what you will see the least are properly proctored exams, where you write an exam that looks like a normal exam and there is some monitoring software or even less likely in-person proctoring. So instead, you will most likely see evaluations that don't require proctoring. So that means professors are moving towards non-traditional types of exams, shifting the weight to other components of the courses, asking exam questions that are different from the type of, exam questions that assume open book availability and therefore a different type of exam. So I think the short answer is you won't generally see many proctored exams. I think none in physics.
Great, perfect. We'll move towards our next question. What sort of questions should be sent to program-specific advisors rather than general advisors? So, and can you give us some examples of possible questions?
Yeah, so I guess I can answer that. I'm Stefan Ejak, one of the general advisors. So questions that should go to an instructor are those that are related directly to the content of a course. So if you're having problems with the course, go talk to the instructor of the course. For advisors, it's more general things. What kind of courses should I be taking if I want to do this particular minor or that particular minor? I failed a course and now I'm out of sequence, and how can I recover from that? Or any kind of issues with problems taking courses in general, or you're just looking for general advice on roughly anything. We're there to talk to you. We're there to help. But for the course instructors, generally you give them questions which are related to the course, content of the course, how the course is being delivered, questions about deadlines, things like that go to the course instructor. And I think basically everything else goes to the advisors. Would you agree with that, Richard?
Yeah, that sounds great. Yep, I think.
Mm-hmm.
Great, perfect. So for our next question, I think it's directed to a little bit of Richard. How will the labs be held, and will there be penalties if you miss the designated times?
So I don't know in general.
Yeah.
So I don't know for all courses how labs will be held, but I can speak to the labs that are associated with Phys 121, which you will be in. So generally speaking, what will happen is you will go to the Waterloo bookstore or get delivered a package, which is materials, usually just common household items, but it's a package of materials that will allow you to work on the labs at home. And there will be videos associated with the labs. So you'll watch a video and you'll try to do the lab on your own using these materials. And then you will get together in groups on teams with a TA after you've tried the lab on your own, and you'll discuss the lab. So yeah, that's generally how the labs will work for the labs associated with Phys 121.
Perfect.
If you missed the designated time, I see that's also part of the. So designated time. So what that means is you get together with your group and you decide, when, which session you're going to attend, and the expectation is that you actually attend. I don't know the specific penalties if you miss that session, but I can guess with labs, there's really no way to sort of redo these things. So I don't know how many marks would be deducted, but almost certainly some marks will be deducted if you don't show up at the agreed upon time.
Great, perfect. Another question for Richard while you're answering. How long is the physics prep test?
So think about the prep test as, okay, so in Phys 121, there's a 5% participation mark. So that's participating in a wide variety of things, including the prep test and various surveys throughout the course and so on. So think of the prep test and the associated couple of surveys that go with it. Think of that as part of that participation, think of it as your first week of homework assignment. Okay? And so, you're probably going to spend, a couple of hours on that first participation assignment. I just want to reiterate, it's really important that you do that prep test, both to, assess for yourself where you're at, do you feel ready, and for us to see where everybody is at so we can help people the best.
Great, perfect, thank you. Another question. I'll leave it open for who wants to answer this one. It's been communicated that collaboration looks different in university than high school. What would be some physics example of authorized and unauthorized collaboration between students?
Do you want me to do that one, Richard, or?
Sure, go ahead. I might add
Or
something.
Amin, did you want to?
Amin?
Yeah, go ahead, Amin, if you'd like to.
I just like to start, I'll mention from my personal experience. Me personally, I study a lot better in a group because there's a saying, if you're able to explain the content that you're learning to someone else, you end up learning it yourself as well a bit better. So I've spent countless nights in phys club sitting with a group of friends studying for tests and preparing for midterms. So for me personally, that's a good example of authorized collaboration where you're kind of studying with a group of people. And an idea of unauthorized would be if you were actually especially since it is an online term, if you were collaborating on tests or using some online forums or something like that, that would be an unauthorized collaboration. And maybe Professor Epp and Professor Ijek, you can expand on that as well.
Yeah, go ahead.
No,
Richard.
go ahead, Stefan.
Okay.
Stefan, go ahead.
So I would put it a little simpler than that even. And if it hasn't explicitly been permitted, then it's probably unauthorized. In terms of work that's being submitted, right? Studying together is perfectly fine, right? And some courses don't even want students to work together doing assignments. I think that would be in the minority. If that's the case, then working together would not be authorized. But essentially, the course outline, which is the document you get that describes how the course is operated, tells you what you can and can't do. And if it's not in there, then you shouldn't be doing it. And consequences can be severe for unauthorized collaboration. They range from minor grade penalties to suspensions, and those are applied. Generally, going to websites like Chegg or similar types things, they'll get you in trouble. Right? I think is a good rule of thumb also.
Can I just add a little bit to that? But I agree with everything you say. What's acceptable will vary from course to course. So I think a mistake I've often seen students make is to say, well, this type of collaboration was okay in this other course I took, and then I got in trouble for it with this other course. Read your course outlines, and if anything is unclear, ask the professor, and don't assume that what applied in one course applies for another course.
So, for example, I could speak to Physics 121. So in Physics 121, there will be group collaborative discussions happening, but there's also preparation for those group discussions. So there will be, the expectation that you do a certain amount of work on your own, and then you get together in a group and you discuss. And so there's both components. So as Michael said, just read the course outline carefully, and the course outline should make clear what level of collaboration is expected in the various course components. I mean, another thing just to say, just generally, is think about a test. There are certain circumstances in which it's clearly no collaboration is allowed. I mean, think about a test or an exam where you are by yourself. There is no communication whatsoever with anyone else, and you are just, answering questions to the best of your ability in that circumstance. So that's so in some courses there will be tests or quizzes or maybe even a final exam with that expectation. I had just an anecdotal example. A student, wrote an online exam and said, "Oh, my sister helped me with the exam while I was doing it. Is that okay?" Well, no. I mean, tests and exams, they're designed to be just you, right? So, use some common sense here. And as Stefan said, there are penalties for this. And so it's really, really important to maintain your academic integrity just for yourself. Your goal is to learn. You don't want to, yeah, that's enough.
Great, perfect. I'll move on to another question right now. I believe this one is also directed at Richard. So give me a second. For accurate testing of our abilities, are we encouraged to prepare for the prep test or not? Does this test count to the course grade, and is it open book?
Okay, so certainly do not prepare for the prep test. The idea is, where are you at right now? It's just sort of like an indicator of that. So just, go into the test cold, and there'll be some physics questions, there'll be some math questions, and they're sort of like carefully designed to help us see where it is you're at. You want sort of an honest assessment of where you're at right now. So do not prepare for the prep test. Don't worry about it, anything like that. Just show up and do it. Does the test count to the course grade? No, it does not. The grade that you get, or how well you do on this prep test, in no way whatsoever affects your Physics 121 grade. The only effect on your grade is whether you participate or not. There's a participation mark. It's, as I said, part of the 5% participation mark in Phys 121. So it doesn't matter how you do. Okay, is it open book? No. So here again is an example. Think of this as a test where you are in a standard test environment where you're sitting at a desk by yourself, working by yourself. We want to know what you know, just sort of in your own head, without access to the internet, the knowledge on the internet. So it's closed book.
All right, great, perfect. Thank you. We'll answer one last question. We'll try to get this wrapped up by 12:30. So it lasts an hour approximately. So one of our last questions is, what will happen if I'm sick during my exams? Anyone can answer this question.
So I can see that there's an answer provided here that's been sort of cut and paste in here. I mean, generally speaking, yeah. So generally speaking, in sort of non-COVID times, what would happen is, if you're sick for your exam, and you sort of know before you enter the exam that you're sick, it's very important that you don't write the exam and that you go see a doctor and you get a verification of illness form, which can excuse you from the exam. It's at the instructor's discretion, but can excuse you from the exam, and maybe you have a deferred exam. So it's important to sort of indicate that before you write the exam. But after you write the exam, then whether you were sick or not, it doesn't matter. You've written the exam. That's, I think, one thing to say. Maybe Stefan, you could add to that.
Yeah, I think it's really, you're only really excused from exams if you're seriously ill. You're throwing up the day of the exam or something like that. If you have a little, I was gonna say a little sniffle. It's probably not appropriate today to say that, but in the past, right? If you had a little sniffle, then it's a minor illness, and a lot of instructors won't consider that to be an adequate reason to miss an exam. So it's intended for serious illnesses. But yeah, but if you are ill and you don't think you can write the exam, don't write it. If you write it, then you've written it, and that will be your exam grade. But if you are sick and you can't write it, get medical help and get a verification of illness form filled out, and then submit it as described in the course outline. And there's usually a process in the course outline that describes what to do as well.
All right, great, perfect. So before we wrap this up, I'll answer one last question personally, because I think it's a great opportunity to advertise one of our other events in orientation. So we've been asked, how can I find study groups while we are not physically on campus? Well, that's a great question. An answer would be to first of all find friends in your program. For example, you could find Facebook groups in your program. And another answer is on this coming Friday, we'll have an event called Science Showcase run by Orientation, where we'll present some of the clubs. And so clubs are a great way to find study groups, to find friends that are not only in your program, but also have the same interests as you. So go to that, and hopefully that answers your question. And then, all right, I believe it's time for me to wrap this up. Thank you. Well, first of all, I'd like to thank all of our advisors and profs for showing up and for sticking with us through these difficult times and technical difficulties, but thank you very much to everyone who's here. Thank you again. Also, thank you for our students who are here. If you'd like to turn on your camera, everyone who participated today, thank you again, thank you. And then you can say goodbye, and hopefully we'll see you around campus, and we see you in other orientation events. And thank you, everyone. If we did not answer your question, feel free to email sciorientation@uwaterloo.ca, or you can email profs or advisors if you have specific questions for them. Right. Well, thank you for everyone for your patience and sticking with us through all these technical difficulties. And we hope that you have a great rest of your day. Thank you. All right. Bye bye.
Thank you,
Bye bye,
everyone.
everyone.
Welcome.
Bye.
Perfect. Sorry, I'm just stopping the recording, trying to find where that is.